You have to have a calculator in to do this portion of 4.4. Okay, let's talk about the change of base formula. Okay, if you have something like log base, oh wait, maybe we did talk about this.
I feel like we did.
Did we do the change of base? Yeah, we did all of 4.4. Beautiful.
I think we finished this.
We did finish 4.4.
You don't have a lesson.
No, we're on 4.5. Exponential and logarithmic function. Okay.
I'm writing this
Well, you should.
JK Lowell. JK Lowell. Oh. Ruffle.
Okay. We're going to graph. Okay, we have exponential growth and decay that we're going to talk about. Logistic growth and decay models as well. So let's talk about these 5 type of graphs we're going to look at. There's exponential growth. Exponential growth can be represented by y equals a times b, or times e to the bx. Okay? B has to be greater than 0. You have exponential decay. Okay, exponential decay is y equals a times e to the negative bx. Okay? B has to be greater than 0 still. Okay, so the number has to be greater than 0 that represents b, but the negative could make it technically a number that's less than 0. The negative is being multiplied into it. You have something called the Gaussian model. The Gaussian model is y equals a times e to the negative parentheses x minus b to the 2 over c. 4, you have the logistic growth model. That is y equals a over 1 plus b to the b times e to the negative rx. And then the 5th model that we're going to look at today is the logarithmic model. And that is y equals a plus b times ln of x, or y equals a plus b log base, or log of x. Okay.
Wow, that's a lot.
It is. We're going to look at all of these little things. Okay. So,
Are we still using all the other ones that we've already went to?
what do you mean all the other ones?
Like the fractions, like you subtract it. If it's like,
Yes, you have to use the rules of exponents. But on this, you're going to just plug your stuff into your calculator and graph. Okay. Exponential growth, okay? Exponential growth basically is just something very simple that looks like this. It's going to grow in that direction, okay? The basic function is y equals e to the x. Exponential decay is going to come down like this, and it's y equals e to the negative x. These are all just the parent functions of these. A Gaussian model looks like a bell curve. It's going to come up and curve like that. Okay? let's say this is at 4, okay? This model would be y equals 4e to the negative x squared, okay? Just a basic model of what it could look like. A logistic growth model can look like this. Logistic growth is going to have a point that it doesn't cross. So it's going to come, I'm going to raise and go like that, okay? In this case, if my a was 3, let's say that this point is 3 here, it would say y equals 3, and then it would be over 1 plus e to the negative 5x. If I put that equation in, I get that. So that's, oh, I'm sorry, I meant to put apps in them, I must have just left it blank. Yes, thanks. Oh, just so that. Okay, and then you have natural log and common log. Natural log function and common log basically look the same because when I plug things into natural log or into common log, I can get the same answer out, which we worked on last week. So it looks like that. If this is y equals 1 plus log of x, and this is y equals 1 plus natural log of x. Okay, they look the same. They're parent functions. So from there, we're going to input data into charts and we're going to come up with equations of the data. Okay, this is why you need your calculator. Let's see here. If you guys will turn to 366, there's a chart I need us to input into our calculators. So page 366, it says, the table shows estimates of the world population in millions from 2007 through 2013. A scatter plot of the data is shown in the figure at the right. Okay, and then it says an exponential growth model that approximates this data is given. If you wanted to approximate this data, how do we put data into our graphing calculator? Stat, and then we have to do what first? Clear list. So I go down and press enter on clear list, and I press second 1, comma, second 2, and I press enter. Go back into stat, and I press edit. For 07 to 13, I'm just going to start at 7, 8, 9, 10, represent the years that way.
Let me go back to the clear list part.
Clear, line clear.
So second 2.
You hit stat, and then you go down to the clear list, and you press enter.
Did it clear for you?
No, and then you have to press, when you press enter, you have to then press second and the number 1, and then the comma and second and the number 2, and then you have to press enter again.
Where is the comma?
The comma is above the 7. And then you have to go back into stat and press edit, and you can edit your list.
This is it.
So plug that data into your graphing calculator for me, and let's see some stuff. And then
You know, I left it in here. I don't know why.
We gotta pay that paper, right? Oh, no, not that kind of visa. Josh isn't illegal, okay?
I'm more legal than
oh yes, and when you go to graph, remember that we need to create windows that are big enough for this. My x minimum in this case is 7, so I'm going to put 5 just to play it safe. And my x maximum is 13 because of the year 2013, so I'm going to put 15. I'm going to count by ones there. My y minimum is 6,631, so I'm going to just say 6,600. My y maximum is 7,098, so I'm going to say 7,100. I'm going to count those by 50s, and I'm going to press graph. If your stat plots are turned on, you should get boxes. If not, you need to press second and then stat. or second and y equals, and turn your stat plots on. Stat plot 1 and stat plot 2. Stat plot 1 and stat plot 2 has to be turned on.
Wait, what?
You need to turn on stat plot 1 or stat plot 2.
No, like, it just like,
Did you get a graph?
I get a graph, yeah.
Okay.
There we go.
And because this is a logarithmic function or an exponential equation, you're going to go into, we have to come up with the equation for it. They're going to give us the equation for it. If we go back into stat and go over to calculate, it is not cubic, it's not quartic, it's not linear. It is exponential. The one that says EXP, I press enter on, that stands for exponential. And then it gives me all the fun facts of what that is.
Did you put stuff in the second list? Did you put the 81,000, the 88,000 in the second list?
Yes. What 81,000? There is no 81,000. I don't know.
Page 364?
Page 366.
We all make mistakes.
And then when you plug that in, you should get an equation. It says y equals
It's okay.
a times b to the x power, okay, because I chose the exponential one. And so then it tells me a is 6,128. 6,128 equals my a. Okay, I'm just rounding. My b was 1, and my r was 0.9. I'm just going to say, well, it's 0.99, so like 0.1 or 1, but I'm just going to put 0.9. What's a big oof?
Well, I'm not getting the box.
Are your stat plots turned on? Is your window set correctly?
Find out what's your window set. Did I have 5?
My window is set to X minimum is 5, X maximum is 15. I'm counting by 1. My Y minimum is 6,600. My Y maximum is 7,100.
Okay, and then what's your scale?
I counted by 50s. Did you? Okay, then let me see. Do you have stuff in your Y equals? No.
That would make sense. The only answer was ooh.
Oh, you put, here's why. You put 2007 through 2013, so your window has to match that. 2005, 2015. Count by, you can still count by ones, right?
Yeah.
Where I go wrong.
You haven't gone wrong anywhere yet.
That's when I hit graph.
Yes, I bet you your stat plots aren't turned on. See, off and off. So you have to come over here and turn them on. And then you hit second y equals again. Go down to the second one. Turn it on. And then that's cleared. Your window.
Now from here, is this when it says stat again and calculate?
Yes, this is where you hit stat again. And then this is an exponential factor. So you're going to go to the one that says exponential.
I have extra regular.
That's fine. Exponential regression. Press enter there and press enter again, and it should give you all the numbers to fill into your. And remember, if you're a little off from the book answer, that's totally fine because we round differently. Things get put into our calculators differently. So if you're doing the same thing. So this is what I ended up doing. So I can create my equation to say y equals 6,128 e to the b times r, so to the like 0.9. And that's what my equation looks like. Or I think it should. What is point? Yeah. So my equation looks something along those lines. The book has a little bit different than that. So yeah, it just depends. So that is what you're looking at doing in your calculator tonight for homework when they give you charts, okay? Same thing when you model population growth, okay? You're gonna do the same type of function. So everything you do tonight is like this on your homework. Now, they should tell you which equation you're going to use on a lot of your stuff. It's going to tell you use exponential growth, use the Gaussian model, use logistic growth. You just have to be able to plug numbers in from there to solve. Example 4 on page 369 is a way that we can do this. What? I'm not going to make you memorize those formulas, but you need to have them written out. Okay, so on example 4 on page 369, it talks about SAT scores. And it says, in 2013, the Scholastic Aptitude Test, guys, stop talking, mathematics scores for college-bound seniors roughly followed the normal distribution. Y equals 0.0034 times e to the negative, parentheses, x minus 514 squared divided by 27,848, where 200 is less than or equal to x and x was less than or equal to 800. X is the SAT score for mathematics. Okay, it says use a graphing calculator to graph this function and estimate the SAT mathematics score. So what you would do is you would plug that equation that they gave you into your graphing calculator, and then you're going to press that trace feature on your calculator, okay? And when you press that trace feature, you're going to take it to the peak of that Gaussian model to figure out what the average was. It's just like a bell curve, okay? A bell curve usually says that I have some A's, I have lots of C's, and I have some F's, okay? Okay, so the Gaussian model is basically a model for that. So you want to take your trace feature and figure out where the top peak of that, where the 50% range is. And if you do that on your graphing calculator, you'll find that it was around a score of 500, okay? Those are the things you are doing. Everything is being plugged into your graphing calculator to graph or to use the trace feature and find a specific location. Okay? That's what you're doing. Yes, Matthew? Yes.